Colors are found everywhere. They are intrinsic to our world. They seem simple, but they are a complex property caused by physics and biology. So, what is color? To answer this, we must know what is light and how it affects color. Light, or visible light, is a very small part of the electromagnetic spectrum. Its wavelength ranges between 380 to 790 nanometers. Light is created from light sources like the sun or light bulb, in which atoms are given some energy which excites the electrons within, which move to a higher energy level. However, the atoms cannot hold this extra energy, so the electron again moves down to a lower energy level, releasing the energy in the form of a light photon. The photon has the same energy as the difference between the two energy levels, also called a quantum of energy. The photon being released is a packet of energy that oscillates as it moves around. Photons of light usually oscillate at 400 to 790 terahertz, meaning 400 to 790 trillion times per second. Light, like sound and heat, is also a form of energy. Even though it may seem like all light is the same, other than the fact that they can be different colors, well, that is wrong. Albert Einstein established that all light doesn't have the same energy. Furthermore, this energy difference is the main cause for the phenomenon of colors. Of all the colors in the spectrum of light, red has the lowest energy and violet has the highest energy. Now we have a basic idea of what colors are. But how does something receive the property of color? First, the light reflects off of an object. However, when the light hits the surface, only light of certain energies are reflected. Rest is absorbed. This is due to each element and/or molecule being able to reflect or absorb light of certain magnitudes of energy, that is, colors. This characteristic pattern of certain colors being reflected in atoms and molecules is called the absorption spectrum, or when being emitted, the emission spectrum. But how do these energy differences of light affect how we see colors? To understand this, we need to understand how the eye and the brain work together and perceive light. First, the photons of light enter the eye through the pupil and hit the plate on the back of the eye called the retina. The retina is covered with millions of photoreceptor cells called cone cells and rod cells. For our purposes, we will focus on the cone cells for now. There are 3 cone cells, S, M, and L. The cells are more sensitive to different frequencies of light, that is, colors. The S cells are more sensitive to the frequencies around 700 terahertz. The M cells are more sensitive to the frequency around 550 terahertz. The L cells are more sensitive to the frequencies around 450 terahertz and a little bit around the 700 terahertz region. When the light hits the retina, the cone cells with the sensitivity closest to the light's energy sends the information to the brain. Through some complicated method, the brain decodes this information as color. That is color. Thanks for watching. Like, share, and subscribe, and please continue to support my channel.